Hi, hello, and welcome back. We're continuing with our notes on geometric sequences and series from our Module 2B, Day 3. Suppose we're given the second term of a geometric sequence is negative 18 and the fifth term is 2/3. How can I find my common ratio? Well, I know that a sub 2 let's do it this way, that my second term times my ratio to the third power, right? My second term times my ratio to the third power is going to be my fifth term. So I know my ratio cubed is going to be that fifth term, 2/3, divided by negative 18. So I know that my ratio cubed is negative 1 over 27. So that tells me that my ratio is negative 1/3. Right? If I was going to be doing it with a calculator, I can take that answer that I just got and raise it to the 1/3 power. And that gives me that negative 1/3. Okay. If I wanted to find my first term, then I know that my first term is going to be negative 18 times 3 because I can divide by negative 1/3. And so that first term is going to be my second term, right, divided by negative 1/3. And so that first term is going to be negative 18 divided by the negative 1/3 that I got. And so I'll get that my first term is 54. Okay. My kth term, my general formula, right? We said that my kth term is going to be that first term times my ratio raised to the power minus 1, the counter minus 1, excuse me. So I have my kth term is 54 times negative 1/3 raised to the k minus 1 power. So if I want u sub 6, I could get u sub 6 by saying it's 2/3 times my ratio, right? Because 2/3 is my fifth term, which would be negative 2/9. But of course, I could also get it as 54 times negative 1/3 to the fifth power. If I did that on my calculator, 54, negative 1 divided by 3 raised to the fifth power, and I have that negative 2/9. So that's working with our geometric sequences. What if we wanted to add up the terms? All right, if we wanted to add up the terms in a geometric sequence, then we would have a sum of that geometric sequence. All right, and the sum of a geometric sequence is nothing more than a series. All right, so we can say, hey, we have a series summation, right? And that sum of the first n terms of my sequence, which is known as a series, when I'm adding up the terms, can be given by two different formulas. One formula we'll use if the common ratio is greater than 1, and one formula we'll use if the magnitude of the ratio is less than 1. Now, of course, you could always use the same formula, and all this would do is if r was greater than 1, give you negative numbers that you are working with. Where this one, if r is greater than 1, you'll be working with positive numbers. All right, so as an example, if r were equal to 3, 3 minus 1 is positive, but 1 minus 3 is negative. So let's use an appropriate formula to find the sum of the first 12 terms. So if I want the sum of the first 12 terms, I'm going to need, if we look at our formula, I'm going to need my first term, right? 1 minus my ratio. I got to figure out the ratio, and then 1 minus my ratio. So what's my ratio? My ratio will be negative 1.5 divided by 3. And that should be the same as 0.75 divided by negative 1.5. All right. And if I look at that, I should be able to see that my common ratio is negative 1/2. But if I'm not sure, I can use my calculator if it's available to me. and I see that my common ratio is in fact negative 1/2. So I have 1 minus my common ratio, negative 1/2, raised to the 12th power. And look at my use of my parentheses, right? It's going to be very important to use those parentheses so I don't make a mistake with negative numbers. So the sum of the first 12, I'm going to need 1 minus parentheses negative 1/2, right? Close that parentheses. That's going to get raised to the 12th power. And then I want to figure out that number, multiply that number by 3, and then divide by 1 minus negative 1/2, right? And so I see that this sum, right, this sum is approximately 2, right? That it is 1.9995, right? So it's approximately 2. Exactly would be 4,095 all over 2,048. Okay. If you wanted to, you could have done this a slightly different way by saying my ratio is negative 1/2. Let me take that to the 12th power, right? Let me do 1 minus that value. Let me take that number and multiply by 3. And then finally, let me divide that answer by 1.5 because 1 minus negative 1/2 is 1.5. And we notice that I get to the same solution. Okay, so we show our use of our formula, and that'll be sufficient enough for our work. Right? If we wanted to give to our decimal places, we'd be able to. Right? Let me erase this just a moment. So our next question, we have that a flight attendant makes $45,376 during their first year with the new airline, and at the end of each year, they're given a 9% raise based on their current salary. Determine their total earnings during the first 5 years on the job. All right, so what do I know? My ratio is going to be 1.09. That each year I'm going to be multiplying by 1.09 because I'm getting a 9% raise. So if I had 45,376 in the first year, the second year would give me 49,459 and 84 cents. Right, the third year would give me 53,911, right, and 22.2256, so about 23 cents. All right, so notice each time I'm multiplying by 1.09, so that's my common ratio. So if I want the total earning during the first 5 years, that's the sum of the first 5 years, is going to be my first term, 45,376, all right, excuse me, my dyslexia coming through there, 45,376. And we said that if r is greater than 1, I could use this other formula, right, if I wanted to. And so that would give me my first term times 1.09 to the 5th power minus 1 all over 1.09 to the 5th, or just 1.09, excuse me, minus 1. Okay, so what would that look like? 45,376, parentheses, 1.09 raised to the 5th power, minus 1, close parentheses, all over 1.09 minus 1. And that gives me a total of, looks like $271,000 and $271,562.23. So that is my approximate earnings for this flight attendant over their first 5 years. All right. To show you that it would work the same if we use the other formula, 45,376, parentheses, 1 minus 1.09 raised to the 5th power, close parentheses, all divided by 1 minus 1.09. Notice that we get the exact same value. All right. So if you like working with negatives, right, you have that right there. So our next question, write the series summation notation and hence state the sum. And here is our series. All right, remember series has additions. And if I look to this, I have a common ratio equal to 2. I'm multiplying by 2 each time. So I need to figure out how many terms do I have. All right. Well, I know that a sub 1 times r to the n minus 1 has to equal 896. So that means that 7, that first term, times 2 to the n minus 1 needs to equal 896. So what's going to be my value for n? Well, one way I can do it is come to my equation solver. And if I go to my equation solver, I have 7 times 2 raised to my counter minus 1. And that needs to be equal to 896. All right, so if I go through and do that work and I look to solve, my equation says that n would be equal to 8. All right. What's another way to solve that? I can come to my calculator and I know that 896 divided by 7 has to be equal to 2 to a given power, right? And I have 128, right? And so I know that 2 raised to the 7th power is 128. So n minus 1 I know is equal to 7. Right? So therefore, n is equal to 8. But I want the series summation. Right? So summation notation is going to be my sum from my counter. Right? I'll go ahead and use 1. So my counter going from 1 to 8 of my first term times the common ratio raised to the counter minus 1. All right. So how do I do that on the calculator? Let me come to, on the NumWorks calculator, I'll come to my toolbox, head down to calculus to get to the summation, go to my summation, going from the counter equals 1 to 8, and then it is 7 times 2 raised to that counter minus 1. And if I get that, that gives me a total sum of 1,785. All right. Now, those that might take a bit more time, we have 7 plus 14 plus 28, but you'd need to figure out what the next terms were. So 2 times 28 plus 2 times 2 times 28 plus 2 times 2 times 2 times 28. But how many terms is that? And then you'll probably soon start to not be able to tell. And that gives us a sum of 441. But really, what's 2 times 28? 56. What's 2 times 56? 112. What's 2 times 112? 224. What's 2 times 224? 448. So really what we have is 7 plus 14 plus 28 plus 56 plus 112 plus 224 plus 448 plus 896, and that gets me to 1785. I'm sure if it was more than 8 terms, that would become a lot harder to do. So notice this one, you had to write the summation and then use that summation to find the total sum. Okay? And lastly, right, what if we had an infinite geometric sequence that we wanted to add up, or an infinite geometric series, right, the summation of the sequence? That will work as long as the magnitude of my ratio is less than 1. If the magnitude of my ratio is less than 1, the sum to infinity is nothing more than the first term divided by 1 minus the ratio. So if I look at the first piece, my indicated sum, what's my common ratio? My common ratio is -1/2. That magnitude is less than 1. So sum to infinity exists. All right, if I look at my next piece and I say, well, what's happening between each term? It looks like I'm dividing by 10, so my common ratio is 1/10. My sum to infinity exists. If I look at my term after that, my common ratio is 2. The sum to infinity then is infinity, right? It does not exist because I will only have an infinite sum if the magnitude of that ratio is less than 1. So what is going to be that infinite sum? Like we said, it's going to be the first term divided by 1 minus my ratio. And on my calculator, 6 divided by 1.5, because 1 minus negative 1/2 is 1.5, and that gives me a summation of 4. For the next one, my first term, 0.3, divided by 1 minus my ratio, 1 minus 0.1, which is 1/10, and that gives me 0.333 repeating, which if we look at this pattern, it seems like that's what it should it be. So that sum to infinity is 1/3, right, which is 0.3 repeating. Okay. Then lastly, write the series using summation notation, hence state the sum. So we need to figure out what's our pattern. If we look to this, it looks like my ratio is multiplying the numerator by 2 and the denominator by 3. That ratio has a magnitude less than 1. So my infinite summation, right, is going to be that first term divided by 1 minus my ratio, right? But it says to use summation notation, so I'm going to write summation notation, and my summation is going to be going from my counter is equal to from 1 to infinity of, it's a geometric series, so 5 times that common ratio raised to the counter minus 1. And it doesn't matter which approach I use on my calculator. I can say 5 divided by 1/3, or I can go to that toolbox, use my summation going from 1, right? Well, how am I going to get infinity in there, right? Well, let's start with the kind of big number and we'll adjust if we need. So 5 times 2/3, right? And that 2/3 is going to be raised to the counter. Oops. Let's see, why is that not working? Let's try again. Let's do this. I know what happened. Okay, so let's try again. 5. Let's see. I don't want that. What number do I need to pass? So my alpha. Let's clear, shift, clear. Let's try it again. So, my gosh, I'm going to refresh. I know what's happening. So let me refresh, come over, let's go to my toolbox, come down, calculus, summation going from 1, get a big number, right, 5, right, 2/3 is my ratio, and then that's going to be raised to the counter minus 1, and we notice that that gives me the same value of 15 that we got before. So the issue that I had before was that I pressed that alpha key, and that alpha key then changed everything to be the little letter characters at the top. So refreshing can take care of that issue. But if I have an infinite sum of a geometric sequence or geometric series, that sum exists only if, that sum exists only if that ratio has a magnitude less than 1. Right? So if -1 is less than r, which is less than 1, and of course r not being 0, otherwise I have no sequence, I have no series. So that's our notes for working with geometric sequences and series. Thank you for your time. Please ask questions where you need. Come back and visit us as you need to understand more about mathematics and pre-calculus.